This is the graph problem from the 2014 AP exam. It's question 3. I believe it's a non-calculator question. They tell you that you've got this function defined on a closed interval of -4 to 5. It consists of 3 line segments as shown in the diagram. There's a second function g defined as the integral from -3 to x of function t, of function f, and there's our function f. It goes on to ask us to find g of 3. So remember, g is essentially the integral of this graph, specifically the integral from -3 to f of that graph. So let's see what we've got there. All right, so part A, I'm going to try to find g of 3. So that's the integral from -3 to 3 of f of t dt. Should just be an area under a curve. So we're looking for the area from -3 back to 3. So let's see, that's a triangle with a base of 1, 2, 3, 4, 5, and a height of 1, 2, 3, 4. Half the base times the height would give that an area of 10. And then I want the area over to 3. 3, it appears, you know what, this slope is not, that's not a consistent slope, I don't think. Let's see, that's the point -4, 4, or 4, -4. And then that's the point 1, 2, 3, 4. No, actually, I think that is a slope of -1. Okay, I think it's going to work out okay. The slope there appears to be -1. So, so anyway, that's a 1 by 1 triangle. And so I should be able to basically subtract that, or is it 1 by 2? Let's see, the slope here, oh, the slope is, it's a 2 by 4. Change in y is 4, change in x is 2. So 4 over 2 gives me a slope of 2. Okay, so this goes over 1 and goes down 2. That's a 1 by 2 square, so the area is essentially -1 is going to be the integral of that. Okay, so the integral from -3 to 2 is equal to 10 minus 1, and that should be an answer of 9. Okay, so just area under curve, very straightforward. All right, part B. Part B says, on what intervals between -4 and 5 is the graph of g both increasing and concave down? So we need g prime to be positive, we need g double prime to be negative. Remember here, if g is equal to the integral from -3 to 3 of f of t dt, then g prime is just the derivative, oh, I'm sorry, it's not from -3 to 3, it's from -3 to x. Sorry about that. So the derivative of the integral is just going to be the function at x, whatever this functional value is here. The second derivative is just going to be the derivative of f. So again, if you go back and look at the question, I'm looking for places where the graph of g is increasing and concave down. So we're looking for positive g prime, which is positive values of function f, and we're looking for concave down, which is going to be negative values of f prime. Okay, so negative values of f prime, positive values of f. Okay, so if we look at this graph here, we're looking for anywhere where the functional value is positive, which could be anywhere here, 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 not over here, but the slope is negative, because f prime, which is really g double prime, needs to be negative. So we have positive functional value, negative slope, so from -5 over to -3. That's one of those regions. So -5 to -3. Okay, and then do we have any other positive values with the negative slope? Yes, starting again at 0 and going over to 2, we're going to have that as well. So x is between 2 and 0, and we should have those two intervals. So again, all based on the fact that g prime, which is f, just means we need to find positive functional values, and g double prime, which is f prime, means that f prime needs to be decreasing because we need a negative second derivative of g. All right. Part C. Okay, this time they give you a function and they ask you to find the derivative. So this is kind of weird because you've got an abstract function here. But all you're really going to be doing there is applying the quotient rule. And so we have g of x over 5x. And quotient rule, or at least Forrester's variation of it, says take the derivative of the numerator, g prime, times the denominator, minus the numerator times the derivative of the denominator, which of course is going to be 5, all over the denominator squared, which is going to be 25x squared. And specifically here, this is asking us to find h prime of 3. So I'm going to fill 3 in there. So I need g prime of 3 times 5 times 3, which is 15, minus g of 3 times 5. And then let's see, on the bottom here, 3 squared is 9. 9 times 25 is 225. Okay. And let's see, to finish working this out, g prime of 3. We know from earlier that g prime is the same thing as the functional value of f. So we'll go look at f of 3. F of 3 here, 1, 2, 3, that goes down 2. That's negative 2. And g of 3, g is the integral from negative 3 to x. So g of 3 is going to be the integral from negative 3 to 3, which we found earlier to be 9. So we're going to fill that in here. And so what do we have? Negative 2 times 15 is negative 30. Minus 45 all over 225. And that ends up giving me negative 75 over 225, which simplifies down to negative 1/3. Looks good. Okay. Take a look at the last part. It says function p is defined by this equation. It says find the slope of the tangent line of the graph at the point where x is equal to negative 1. Okay, the slope of a tangent line, of course, is going to happen where you have a derivative. So let's see. So we're going to take the derivative here. You take the derivative, our original function is f of x squared minus x. To take a derivative, you take the derivative of the outside function. The inside function doesn't change. But then you multiply, according to the chain rule, by the derivative of the inside function. You get something that looks like that. We're trying to find the slope when x is equal to negative 1. So that's going to be f prime negative 1 squared is 1. Minus negative 1 should be 2. And 2 times negative 1 is negative 2, minus 1 is negative 3. So it's going to be f prime of 2. Let's go look here. The slope at 2, which is right here, the slope is negative 2. So we're taking negative 2 times negative 3, and we should get an answer of 6, which I believe is the correct answer. So let's take a look at the scoring guide here. Got the whole problem in the guide. Part 1, you can see there we got that answer of 9. We picked up a point. Second part, we got the intervals between negative 5 and negative 3 and 0 and 2. And our reason there got us another point, so we're up to 3. Here we took our integral, substituted in, got negative 1/3, another 3 points if we show the work. And then finally at the end here, showing that derivative actually gets us 2 points, and then subbing in values and getting the answer gives us a 1/3. So this is becoming a pretty typical problem on the AP exam, especially these, well actually both parts, having that integral defined function at the top part, and then the second half, those kind of general equations that you're taking derivatives of. First problem I'm going to look at is from the 2016 AP exam, the AB and the BC exams. And this is one of the problems that involves showing you a function, and you have another function based off that function. So you can see here, for values of x between negative 4 and 12, they've defined function g of x as the integral from 2 to x of function f of t dt. This is a graph of function f, not function g. So they're going to ask me various questions, probably mostly about function g, and I'm going to have to think about how f and g relate. So part A asks me, does g have a relative minimum, a relative maximum, or neither at x equals 10, and it wants me to justify my answer. Well, if you think about it, a relative minimum or a relative maximum happens when the derivative of your function is 0 or undefined. And so that's what we're going to be looking at in this particular case. So if you take a look at my function here, my function is g of x equals the integral from 2 to x of f of t dt. And I want to know where the derivative of function g is going to be 0 or undefined. Okay? So if I want to find g prime of x is going to be equal to the derivative of the integral. Some books call this the second fundamental theorem of calculus, but just in general, the derivative of an integral function is going to give you basically back the original function, except in terms of your new variables. So this is going to be function f of x is the same thing as g prime. And I want to know where g prime, which is f of x, is equal to 0 or undefined. Okay? And if you look over here, we don't have any places where f of x is undefined. So f of x is equal to 0 at -2, 2, 6, and 10. Those are all the places where I have a possible relative minimum or maximum. So I use number lines. So I'm going to make a note here. This is a number line for f g prime, which is the same thing as f. And again, I'm looking for places where g prime, which is f, is equal to 0. So if we go back here again, on my number line, we're going to have values where the function is equal to 0 at -2, at 2, 6, and 10. Remember, I care about the derivative being positive. That tells me the function g is increasing. Or I care about g prime being negative, and that tells me that function g is decreasing. So g prime is the same thing as f. So I'm literally just looking for positive and negative signs of function f. So notice that function f is is negative all the way up to -2. So f is negative. That tells me that g prime is decreasing that interval. Okay, if we go back there, notice that function f, which is g prime, is positive between -2 and 2. So that tells me that function g is increasing. Okay, continuing between 2 and 6, the function stays positive. So f, which is g prime, stays positive. Between 6 and 10, you can see that f, which is g prime, is negative. So the function is decreasing. And then finally, f is negative again. It means that g prime is also going to be negative. So I have a number line that looks like that. Basically, my original function g goes down, goes back up. That's going to be a relative minimum. Goes up, levels out with the derivative of 0 here, and then it continues to increase. So this is a place where we have a plateau point. Reaches a maximum, starts going back down. So that's a relative maximum there. And then if you notice, the question asks us what happens at x equals 10 and asks us to justify our answer. So if you look at 10, there's neither a maximum nor a minimum because the derivative of g, which is f, does not change signs at 10. So I can say something like g has neither at x equals 10 because, oops, it's supposed to say because g prime, which is the same thing as f, does not change sign at x equals 10. Okay, so that's my answer for the first part. Part B asks me if the function has a point of inflection at x equals 4. So we're looking at this place right here. Remember, point of inflection is the second derivative. So I want to find the sign of the second derivative of function g. Okay, we go back up here. If g prime is f, to find the second derivative, that's g double prime. And that, of course, is going to be equal to f prime. So I'm looking at values of f prime. I want the sign of f prime when x is equal to 4. Well, f prime sign, f prime is going to be the slope of graph f. So if I go to 4 and I look at the, again, it's asking me if there's a point of inflection. So that's going to be whether or not the concavity changes. Okay, the concavity is based on the sign of g double prime. G double prime is the same thing as f prime. So if you look at the slope here, f prime is positive coming into 4, and then f prime is negative going out of 4. We have a change in sign. I could draw a number line for that, but this is a pretty basic idea. So because f prime, which is the same thing as g double prime, changes signs at 4, we do have a point of inflection. So I'll say something like, yes, there is an inflection point at x equals 4 because g double prime, which is the same thing as f prime, changes sign at x equals 4. Something like that. Okay? And then we can go on to part C. Part C asks us to find the absolute minimum value and the absolute maximum value of g on the interval between -4 and 12. It wants me to justify my answers. Okay. Remember that relative maximums and minimums happen at the endpoints of the interval, which of course in this case is going to be -4 for x and 12 for x, or where the derivative of the function, and keep in mind we're talking about function g here, where the derivative is equal to 0 or undefined. Well, in this case we don't have, g prime was not undefined anywhere. So we're actually going back and looking at all these places on the graph earlier, the critical values, where g prime was equal to 0. And we want an absolute maximum and an absolute minimum. So really, I'd just like to find the functional values at each of these points. Remember that function g is an integral function. It's an integral from 2 to x. Of course, an integral is really just an area under a curve. And notice that this is a very geometric graph, so I should be able to find areas under this curve, no problem. So I'm going to come down here, and I'd like to find the value. I'm going to try to find g of 2 first. G of 2 should be very easy because g of 2 is just going to be the integral from 2 to 2 of function f of t dt. And of course there is no change there, so that integral should just be 0. So that's g of 2. So that's what's happening there at 2 for function g. Remember, this graph is function f. Okay. If I look at my graph, I can find values of g of 2. That might be a relative maximum or minimum, like critical values. I can find value of g of 6. So I can come back here. G of 6 is equal to the integral from 2 to 6 of f of t. So that's just going to be the integral between 2 and 6. Remember, the integral is the area under a curve. This is a triangle with a base of 4 and a height of 4. So that area is going to be half of 4 times 4, which is 8. And so that's my value of g of 6. So g of 6 is 8. Next, I should be able to find g of 10, which is the, is that the end of my interval? No, it says up to 12, actually. So we're going to find g of 10. G of 10 is the integral from 2 to 10 of function f of t dt. Well, I already know the integral up to 6 is 8. So I really just need to add on, up to 6, the integral is 8. I really just need to add on this region here that goes up to 10. Notice that's also a 4 by 4 triangle, which is just going to be a negative 8 area. So we have a positive 8 up here. We have a negative 8 there. And those two are going to offset each other, and that's going to give me a functional value of 0 there. Okay? Then I want to find g of 12. G of 12 is the integral from 2 to 12 of f of t dt. And keep in mind, of course, that that really is just, I can just add on to 0 that last part there, because I know the integral up to 10 is 0. This is a 2 by 4, which should have an area of negative 4, or I guess an integral of negative 4. And so g of negative 12 is going to end up being negative 4. I do have one other value to find. I need to find g of negative 2, right? I never found g of negative 2 yet because I started at 2. So we'll look at g of negative 2. G of negative 2 here is the integral from 2 to negative 2 of f of t dt. Notice that my bounds are backwards. So I'm going to switch the bounds, and that'll change the sign. So I'm going to take the integral from negative 2 to positive 2, but I'll change the sign. I'm going backwards, basically. And let's see, if I do that, well, I'll change the sign at the end from 2 back to negative 2. And notice this area is, it's a 4 by 4. That area is 8. But it's going to be the opposite sign. So it's going to end up being an area of, or an integral of negative 8. Let's see if I can get this to focus. And then finally I want to find g of negative 4. G of negative 4 is going to be the integral from, it would be 2 to negative 4, but I'm going to do negative 4 to 2, and I'm going to switch the sign to negative of f of t dt. And again, we go up here, and we already know that that integral before was negative 8. It was backwards here. This area here is going to be negative 4, but we're changing the sign, and that's going to make it a positive 4 being added to our previous value there. So we have negative 8 plus 4. That's a value of negative 4. So if we're looking for the maximum value here for this function, notice the maximum value here is, we have a maximum value here of 8 for the function. That's when g of 6, when I find the value of g of 6, and the minimum value here appears to be negative 8. And so hopefully that is all correct. It does appear to be right. Okay, the last part, they asked me to find all the intervals for which g is less than or equal to 0. Well, because of what I set up here, this is going to work out pretty nicely. Remember, these are all the places where the graph changes direction potentially, so we should be able to use the intermediate value theorem here and just see what values it passes through. So how many times is this graph less than 0? Well, it goes from 0 to 8, so it's always going to be positive in that range because it never changes direction again in that interval. From 6 to 10, it's going to go from 8 back to 0. Those values are all going to be positive. From 10 to 12, it's going to be negative. So between 10 and 12, the function is going to be negative. And let's see, then from, let's see, 12 is the end of the interval. If we go from 2, if you look at 2, it's kind of out of order now, but 2 is at 0, and then g of negative 2 is negative 8, and g of negative 4 is negative 4. So from negative 4 to 2, the function is also going to be negative. So let's see, between 10 and 12 and negative 4 and 2. So let's take a look at the scoring guide now. Let's see how this all stacked up. You can see the actual scoring guide here and how they did this. So the first part there, you get a point for that g prime being equal to x. You get a point there for the answer with your justification. Part B, the inflection point. basically that G prime changes signs, or you could say that G prime is increasing and then decreasing. That's G double prime changing signs, or G prime increasing or decreasing. You see the different functional values there. It's in part C, and you can see the points there. And then part D, just getting those intervals right, gives you your final point. And that's that problem.